Hello everyone, I'm Harry, and this is my final project, Real-Time Procedural Terrain Generation. In this project, you only need to input a few parameters, and you will get a high-resolution realistic terrain. Terrain generation includes 4 steps. They are noise map generation, Voronoi diagram, thermal erosion, and hydraulic erosion. In this demo, the output is a 1024 x 1024 height map. First, let's look at noise map generation. In this process, I use diamond square algorithm to generate fractal noise. First, we need to generate a midpoint in a square, and then generate a midpoint for each edge. The height value of each midpoint is the average of its neighbors plus a random offset. The magnitude of the offset decreased by half for each iteration, and we need to do this recursively. The data structure I used is very similar to what I used in Catmull-Clark subdivision. I have 3 different pointer-based classes, which are point, edge, and square. Each of them stores the pointer to their neighbors. Voronoi diagrams can be used to simulate hilly terrain. To implement this, first we need to get a list of random points, and then for each point in height map, we calculate the first and second nearest distance to all random points. And we can get height value by using this formula. We can get different results if we use different C1 and C2. For instance, if we let C1 equals -1 and C2 equals 1, we will get the bottom right image. Thermal erosion is a result of melting and weakening permafrost due to moving water. It can reduce the average slope of a terrain, so it can smooth the terrain by dropping materials from each point to its lower neighbors. I used a particle-based algorithm to implement hydraulic erosion. First, a droplet appears at a random point. Then it moves because of the effect of gravity. The velocity can be calculated by using surface normal. It keeps absorbing soil until its sediment reaches max value, which is proportional to its volume and speed. At the same time, it evaporates and its volume will decrease. Therefore, it will start to deposit soil. Finally, it will disappear because of evaporation. The code of this algorithm is extremely simple. All you need is the particle structure and 20 lines of code. Let's look at the demo. First step is to generate a base terrain by using noise map and Voronoi diagram. The base terrain is an addition of noise map and Voronoi diagram, so we can change the ratio between these 2 maps and get different results. If you change the ratio to 0, you will get a 100% Voronoi diagram. And if you change the ratio to 1, this is the original noise map. If we use different ratio, we will get different results. The default ratio of this demo is 2/3. Let's see the results of thermal erosion. Thermal erosion can smooth the terrain and reduce the average slope. Now let's try hydraulic erosion. We can see the beautiful paths generated by particle movements because of this algorithm. Since the results of hydraulic erosion is quite noisy, we can use thermal erosion to smooth the terrain to get better results. Now we have a beautiful procedurally generated high-resolution terrain. We can try to generate another random terrain. It took me around averagely 10 seconds to get a new terrain on my PC. There are currently two problems now. If I want to build a huge terrain, I need a large amount of memory. For example, if I want to build a 4K terrain, it will cost me about 10 GB in RAM. I might need to change some of the data structures and learn more about how to manage memory. On the other hand, although I used multi-thread to handle some of the computations, it's still quite time-consuming. One solution is to implement this fully on GPU. This could give me a huge acceleration. This is my final project. Thanks for watching.